see. Right. First of all, why we need DNS? Enable DNS. Yes, exactly. So, I mean, we are not good at remembering numbers, right? We are good at remembering names. So we don't go and say, hi, what is ID number, how are you? Right? We don't do that, right? We just call from their name and then ask, let's say that's then read. So in the similar way, we need names because we can't remember these IP addresses. But even though we give names, the computers wouldn't understand those things. But since we need names to remember things, remember locations or URLs or whatever, the need of names are there. So So these computers, they don't understand names, therefore there should be a way to resolve these names into the IP addresses and the other way as well, right? So therefore we need these DNSs, right? So now one way of having these records is like, let's say we keep our own record of these entries, IP address and name. Right? We can have list of IP address and name. Right? Let's say for to the sites we visit, can keep them, right? So, but this is not very feasible way of doing it because now let's say every person is going to keep a record like this. Then if a particular site get added or updated, then there should be mechanisms to change these things. So it's very difficult because this is so distributed and so isolated some of the times because we can't expect everyone to be online when the syncing happens. So we can't expect these get synced. But this file is still there in our machines, right? Kind of a similar file in Ubuntu etc hosts, right? The kind of similar file is still there. So therefore the need of centralized entity or centralized system for this is needed, right? So that is domain name service. Though it is centralized, again the the records they keep are distributed, right? For example, if you try to keep this record at a central location, then now we talk about initially we are in our machines we are going to keep these records. It is not feasible, right? So let's say we are going to keep this record in a central location, and all the machines are going to ask or request name resolutions from them. Again, it is not feasible because then these guys will have to handle so many queries, right? So many queries. Now, let's say handling queries is okay, but updates, right? So if there is an update, there could be updates from so many locations, right? So it is very difficult to manage those things. So to manage these records, what they have done is they have made a hierarchy of these record keeping. Okay, so hierarchy of this record keeping. So it has been these record keeping has been distributed in a way, right? But the initial query will anyway come to this point. Now, if you don't know about something, the initial query will come to this point and it will direct how the rest of the thing happens. So, we'll come to that later. Okay. Now, okay. So, this is actually resolving name. Now, we have, let's say, google.com, google.lk, and we need IP address. So, this is now we are going to query this guy, and somehow he will give us an IP address, right? Let's say for now. And these DNSs also support the other way. When you give an IP address, it can give the name, right? When you give an IP address, it can give the name as well, right? Okay. How name resolution works in Linux? Let's see. So this is not security basically. This is about we are still learning about DNS. So there are a few main files that is related to this DNS resolution in Linux, right? One is, as we mentioned, etc hosts file. The other one is etcresolve.conf, and there's another file called ns switch, right? So now open up and see what etc hosts file look like. Mau tekan terminal?
Ya, mana?
Right? There you would find that IP address or domain name. First is domain name, right? In etc hosts. Munitian domain name is IP address and then domain. There's a mapping, right? So what I want you to do is make the IP address 127.0.0.1 and for the domain www.google.com. So put an entry like, let's say, you have to figure out the entry based on the entries that you have. Right? Now, get a browser. Right? So, do you have desktop installed in your? You are installed in your VM. Okay. Grab a browser, or I don't know, you can use curl otherwise. Grab a browser and go to www.google.com. And you have to save that file. It is your host file. You have to save it. What happens? Go to www.google.ak. So it's not an internet problem, right?
Yeah.
So it's trying to find google.com in this IP address. Right? In this IP address, right? Okay, now try ns lookup on this. Take a look at the IP address.
Still show it still shows early.
Sorry?
It still shows early.
It is still
Shows
yeah, it's still showing the previous public IP, right?
Yeah.
So it is not 120. It's not that way.
Look up, space. Oh, running.
Configuration which tells these lookups of data the sequence of finding these resolvers, right, or finding these name entries. So in Linux that file is in etc ns switch, name server switch. Right? Go to that file and see what are the entries are there. So in that there is an entry for DNS. Sorry, not for DNS, entry for hosts. And entry for hosts. So in this hosts entry, what is the first parameter that has been given to the host? Files. Then
MD space MD.
That is something then local domain search. That's fine. And after that DNS.
Not found return.
Yeah,
DNS.
the DNS. So this file means you have to first look at etc hosts. That is what mean by these files. And DNS means you have to go to the resolver and see what are the resolutions. Right? So if you couldn't find a resolution in etc hosts, it should go to the resolver and find a resolution. Okay, so that is what this NS switch specifies. Okay. Now seems the browser is doing it, but not NS lookup, right? NS lookup is not doing it, which means NS lookup is not referring to this. It is directly referring to the resolvers, right? So therefore, when we want to, now sometimes we want to host something locally and have a domain name, right? And if you want to, in command line, check those things, there is a different command that you have to use. That is this. Type this and see. In non-local IP.
Yeah.
Right? Okay. So if you want to test these name resolutions in command line, then you have to use get. Right? If you want to test like let's say whether this NS switch is working. Otherwise, if you want to directly go to the resolver, then you can use DEET or NS lookup. Okay? Right. Now, what is this resolver? So, we look at how this resolution happens. Now, when it comes to your machine, you are using maybe a mail client or web browser. So what that program does is it tries to refers to the resolver. Now these browsers and all that has a mini cache, but the problem here is normally this is mostly they are used for content caching in browser, not for resolutions, right? They aim for content caching. So when it comes to resolver, now we configure these resolvers using the name server entry in etc.resolve.conf. You can have this resolver locally, right? Actually, by default, by default, the local resolver will work, right? And this resolver will specify the sorry. Now this actually specifies the name servers or recursive name servers. So before that there is a local resolver, right? Before that there is a local resolver where when you type something in the browser, it goes to the local resolver service and see if it can find it there, the local resolver service. So in a different operating system, the service is different. So we'll have a look at that. What are the resolvers that we have? So after that, now this resolver has a local cache, right? And if that is not available in the cache, then it goes to the DNS name servers specified in the resolve.conf, right? Then it goes to name servers specified in the resolve.conf. Now in this case, the DNS means with DNS means you are going through the resolve process. So local resolver comes first. After that, it goes to these things, right? Okay. So now let's say you had it in the cache, then it get resolved in this local resolver itself. It is not the resolution process does not go beyond your machine, right? So if it is not there only, you are going to the external resolvers. It could be your ISP, Google, or maybe another resolver that you have installed in your machine. You can install a DNS server in your machine to act as a resolver, right? Okay. So now when it comes to these caches, there is a problem because now how many of you have learned? You should have learned ARP poisoning, right? So there is a cache poisoning attack. How we do that? So someone is requesting a MAC address, right? For a particular IP address. So instead of the original request, someone else gives a false MAC address where you keep a map of it in our table, right? So that is how ARP poisoning happens, because now so ultimately you end up with a wrong IP address for a particular MAC address, right? So that is how ARP poisoning works. Now generally any cache poisoning works like that. Any cache poisoning works like that. Now all these caches, if there is a cache, a poisoning can occur, right? So in networking, right? So let's say it applies to everything as well, right? So when it is like, let's say here, some program from inside could poison this cache, right? So if it is external, right? Now let's say now one way to poison this is some program internal. The other way is now when this guy requests for a new name resolution, before this particular actual resolver send you the response, some middle party can send a response to you, so that you will put it as your entry and you will be going to a wrong site based on because of that poisoning. Right? Okay. In poisoning, how do you resolve that problem? Filtering at which location? Yes. So you can enable port security in switches, right? So there are different mechanisms that they use to, let's say, reduce the possibility of this poison. One is you can bind a particular port to a particular MAC address. Then the problem is the flexibility will be reduced. The other way is to you can I can't remember what exactly the other way is. Anyway, using port security in network switches, you can reduce, not totally remove it. You can reduce it. So if you have to totally remove it, you have to bind the MAC address to the particular port, right? So that is one way of doing it, and there are other ways. Like let's say there are sticky MAC address, sticky option in the ports. I can't remember exactly. So sticky, right? So you would have you thought about it in the classes? You were. So port security product ඒකේ තියෙනවා එක ඇයි DNS port security
sorry DNS DHCP
no DHCP එකේ තියෙනවා එක තමයි DHCP now when someone is attacking actually in DHCP in your switch you can actually have a dedicated port for the DHCP server where only that particular port can be port can actually send what is the response DHCP response when for a discover කරන මොකද ඒ response proposal can't really. Anyway, that particular packet or information can only be sent by that particular port, right? So ඔගොල්ලෝ DNS කරන්නේ sorry DHCP මේ කරන්නේ starvation attack එකක් දීලා ඊට පස්සේ මේ පැත්තට වෙන response එකක් එනවා. ඔයාලා actually කරන්නේ attack එක ජීවන නිකන් වෙයි.
PC එකේ අර දාලා PC එකේ අර software එක දාලා
ඊට කැප් එක දාලා බලුවද?
නෑ ඊට කැප් එක වදින software එක දාලා අර DHCP server එක තමයි වැඩ මුල කරේ.
ඔව් ඊට කැප් එකේ කරන්නේ
ඈ?
ඔව් ඊට කැප් එකේ කරන්නේ ඒගොල්ලෝ DHCP
කැප් එකේ
salvation
software
එකයි
පොඩි software එකක් දාලා ඒකේම කරන්නේ.
හරි.
අර DHCP server එකක් දාලා ඒකේ
anyway so that attack is possible because in ARP you can't encrypt or you can't sign or you can't do that kind of a control because it's very low level, right? So in here as well you don't have any encryption or anything like that, right? In the DNS queries, so that problem is there. Okay, so let's come to this DNS, why we need DNS and what these caches do. So can you read this? So these DNS caches are mainly used for performance reasons rather than going to the catering queries at every instance. Since these websites don't change like let's say very often, you can keep caches, right? So these caches do expire, right? So because otherwise there is no other way to sync the new changes to the clients or other subdomains, right? Or other DNS caching servers. So now what happens when an attacker poisons a cache and expires this, the cache get expired? What happens? Then the client will at some time request another new entry. Now the problem is the expiry value also comes with that particular packet. So that expiry value can also be set by these. Expiry value can also be set by these cache poisoning attacks. I need to come again for that, right? Anyway, so if a particular attack can be done or cache poisoning can be done like that for a particular instance, then doing it twice is also possible, right? Even though let's say you can't get control over the expiry time, still you can do it again, right? So it is a matter of capturing your requests by doing a man in the middle or whatever. So man in the middle for a DNS query is very easy, right? Because it is not encrypted. So even though HTTPS traffic is encrypted, before going to the HTTPS you will be doing a DNS query, so that you can intercept that and then poison the cache and direct the client to a place you want, right? Okay, so now as I mentioned earlier, in your system there is a resolver. Now when it comes to Red Hat based system, the resolver name is NCST. When it comes to Ubuntu based systems, so there is a systemd service as systemd resolver. See, if you have this service running by using this command, you can check the service. Inactive, right? Okay. So in my case it is active, right? Inactive.
Inactive විල නෑ තව ඉන්නුනේ. Active යට ගාලා තියෙන system එක.
So
සම්පූර්ණ යට ගාලා දෙවන පේජ් එකත් එක්ක.
Okay, so if it is inactive, you can activate it as well, but it's not part of the activity right now. Now when we are doing the system administration process, we kind of make it active and check the DNS queries using Wireshark, and we flush it and check the DNS queries using Wireshark. Now there is a command to flush these caches as well. So if you want to refresh them by force, but after the expiry time, they will anyway automatically inactive. They will anyway automatically flushed entry by entry. So in ARP, how they keep this expiry time? So also ARP entries also expire, right? Expiry time equal Okay. Okay, now let's see. If the resolver does not have this information regarding a particular domain, how the things work, right? So now you have your computer here, and you need to go to, let's say, www.ucsc.lk, right? So this is basically your machine, right? So this is the name server you have mentioned here in this order.conf, right? So that is external, mostly external to the external to your machine. If you have specified 1207001, this part will also be in your machine, right? Okay. So first you query the local computer's resolver to find ucsc.lk, right? So you send a name resolution request, right? Then it will check the cache, right? If it doesn't find it, it will send a recursive query, recursive DNS query to the name server that you have specified. It will send a recursive query. So there are two terms that you need to worry about when it comes to this DNS: recursive and iterative, right? Both words are going close by, but they have different meanings. One is recursive, the other one is iterative. Now when it comes to recursive, you asked someone to do the job, basically, right? You are not doing it, you ask someone to go and find me this, right? So that someone will do it for you, right? So recursively going through the query, okay, where is this, and recursively try to find it, right? When it comes to iterative queries, what happens is you ask someone and you get a response. Now in recursive also, recursive the response come at the last. Now in recursive, you send a recursive DNS request to the DNS server, and it recursively try to find it where this particular domain is, or what is the IP address of that particular domain is, and then it will come up with the result to you, right? But when it comes to iterative query, if you send an iterative query, what happens is, when you for each request you send, there will be a response, right? So the response would be either the resolution, or it could be a referral to another server, right? Okay. So that is the difference between recursive and iterative in DNS. Recursive, when you send the recursive query, the party who receives the recursive query will do the job for you, right, and give you an answer. But when an iterative query, when you send an iterative query, if that receiving party has the resolution, it will give. Otherwise, it will give you a referral. Go and find yourself. Okay. Right. So now this is a recursive DNS query, which means this guy is going to go shopping for you, right? So, thank you. So now, when these recursive DNS servers also have cache. Now it checks whether this query or the name that this guy is trying to find the IP that this guy try to find or the mapping that this guy try to find is there in this cache. So it is, if it is not there, then it will further process it to the root name server, right? So we will come to that again. So meanwhile, in this DNS hierarchy, there are cache only domain name servers, right? So there are few types of domain name servers: cache only domain name servers, authoritative domain name servers, and root domain name servers, and top level domain name servers, right? Mainly these top level root, they become actually authoritative. So mainly cache only, let's say authoritative, and this one more will come there again, right? Anyway, when it comes to these cache only servers, they don't have any configurations, they just run by this cache, right? So they just run by this cache, so you don't need to know about much more information regarding that. But what you need to know is that it doesn't have any configurations, right? So it is a cache, just to improve the performance. Okay, now we were here, right? We were here, and let's say this the resolution is not there in the cache. So what this recursive this domain name server does is, it will send an iterative query to root domain. So these root domains, top level domains name servers, or authoritative domain name servers do not accept recursive calls. They do not accept them because they are not going to do your work, right? So what this guy would do is, okay, send an iterative query to find what ucsc.lk, right? To find ucsc.lk. So when it comes to ucsc.lk, now in your NS lookup output or dig output check, when you have received that output, it says www.google.com, then dot. There is a dot. For UCSC also, there is www.ucsc.lk dot. So this is the root domain name. So this is TLD, top level domain, right? So this could be authoritative, and this may be specified in the resource report, right? So what now? Now when you are trying to find this domain, you are starting from the end. So first you ask from the root, okay, where I can find this. So what the root does is, it will send you, okay, I don't have this typing, but you can ask this top level domain, right, and see where you can go. So it responds with the name server of the top level domain, right? Now how this guy know about this top level domain? Okay. How this guy know about this top level domain?
දුකට
ඔයාට දුක මේ මේකේ කියන්නේ මොකක්ද මේ මේකේ කියන්නේ මොකක්ද ඔයාලා මිසි ගන්න නැහැ කියන එකද Uber Eats
ඔය ජීවිතේ රෝග කැවිලි
ඒක නම් අප්ඩේට් ඕනේ තියනවාද කියලා කියන්නම් කියලාද කියන්නේ
අපිට ගන්න දෙන්න දාන්න
මම කරා කියලා අපේ ඔෆිස් එක
දැම්ම.
දැන් මොකද මේ කියන්නේ කියලා මට තේරෙන්නේ.
අපි වැඩි අනිත් සබ්ජෙක්ට් කරේ කියන්නේ යාගේ අර ඊළඟ ලිස්ට් එක කම්ප්ලීට් වෙනකොට එහෙනම් අලුත් පේජ් එකක් ඇවිල්ලා තියෙනවා.
ගත්තා ඕනේ.
කැසල් වල. මොකද?
Okay. Right. So how does this guy know? Root domain know this about this top level domain?
There's entries root DNS.
Yeah, actually what happens is, now when you want to host a website, you are going through a registration process, right? You are going through a registration process. So you have a registry. So you need to go and register your domain in a domain registry, right? Then after, for the domain registry you give, okay, my domain name server is in this location, so they have record of it, right? So this is this domain is registered and the domain name server corresponding to that domain is there, right? So likewise, let's say you found, let's say, a new country, then if you want a top level domain for that, you need to go and register somewhere in a registration domain, and so it should get approved for this as a top level domain to enter into the root domain, right? So there is a separate administrative process for that. Okay. So then this guy, after approval, this guy keeps a NS record, name server record, for the top level domain. So when a request comes to .lk, this top level domain server knows, so this root domain server knows the name server of the .lk, right? So what it gives here is the name server. Go and ask from this name server, right? Okay. So basically you should understand that this hierarchy therefore linked by name server entries. And this linkage happens by name server entries. So this has a name server entry for this, so it is linked, right? And if this is going to go for another name server, let's say, then there should be a name server entry of that here, right? Okay. So now then what happens is, now this guy has this name server entry of the top level domain. He asks where is ucsc.lk. Then it responds, okay, I don't have it, so you should ask this guy, this name server, right? And then, so all these are iterative queries. Then this guy sends an iterative to ucsc.lk, right? And then finds out, okay, ucsc.lk is here. There is an entry for ucsc.lk here, right? So which means there is a resource record for ucsc, resource record for www in the domain ucsc.lk in this particular domain name server. So in this resource record, it specifies the IP address of this particular domain. So that is the resolution. IP address is the resolution, right? That is the answer you need to know, because the computer doesn't understand these names. So you need to find an IP address. So that is the process. We get this IP address. Now the resolution is there. Okay. Okay. Right. Now on the way to the requester, it keeps updating caches and give the resolution. Okay, it keeps updating the caches and give the resolution. Then the machine can directly send an HTTP request or a service request to the particular server. Okay, by using the IP address. Okay, got it? So this is how this name resolution thing happens. Now there are so many vulnerable points because none of these are encrypted, right? So no security in this protocol. So there are caches where cache poisoning can happen. There are let's say different queries coming here and there without any encryption or any security, right? So this could change, right? So at any place you could be misdirected to a different domain. Okay? Okay. So let's learn a little bit about, now we see this hierarchy like this, right? So as you can see, these servers could be in different places, right? So
Sir, what's the difference between local domain server and proxy server?
proxy server is for a different purpose. Proxy server is for caching the content, not the DNS. There could be local resolver cache for caching the resolved names, but proxy is for caching the content. So again, that is to improve performance, but with respect to the content, right? So when we talk about this content delivery network, the purpose of that is the same. So the content will be moved to a region close to you.
Frequently accessible content.
Yes, exactly. And it is again a cache, and there is again an expiry time. So when we talk about cache, expiry time is there and poisoning is there. So content delivery networks can also be poisoned.
Yeah. What's the difference between NS record and A records?
We'll see. We'll see.
Ah.
Right. Okay. So so now, as I mentioned, there are NS records going here and there, right? So these NS records are used to delegate a particular zone or domain to another server. So that is why otherwise it would be a single file, as we mentioned earlier. Entire single file, right? So since it is difficult,
Side sheet.
TLDs, top level domains, TLDs. So this could be .lk, this could be .gov, this could be .uk, right? So these are linked using NS records. Now if I specify it in a different way, among these records there could be NS records. These are NS records. So So these get linked by NS records. The delegation happens by using NS records. So for this particular GAO, okay, they have their entries. Now for this, it has an NS record for UCSC. Okay, so it contains this. So within this, there is a resource record for www. Okay, which means now if a particular DNS server has a resource record corresponding to a particular entry, like let's say IP address. So we call this domain name server for this particular entry. This is the authoritative server, authoritative DNS server for this particular entry. This has the authority to change this, authority to update it, delete it, whatever, right? So this is the authoritative server DNS for this particular record. Okay. So that is how this delegation happens, right? So this NS is also a resource record, okay? Name server resource record. This is, so it specifies IP address of let's say a DNS. Okay, got it? Now, if someone intercepts this communication and change a NS record, what happens? The delegation can go to someone else, right? Okay. Okay. If you dig and the domain, we call this fully qualified domain name, right? We call this entity fully qualified domain name. So if you dig a fully qualified domain name, this is the output you get, right? So in this case, we call this the resource record, right? So these NS entries are also resource records, but this is in the answering section, we get definitely a resource record. These are also resource records, but these are not the answers, right? So this is authoritative DNS servers, and these are additional information for IPv6 and all. So this is the answer section. So if you carefully look at your Liga output, there is an answer section. It gives you the resource record. So it specifies you have QDN, and this is an entry representing the expiry of this entry, and this is the class. In this case, this is the internet class. We are not going in detail about these classes. This is internet class, and this is the type of the record, A record. A record means an IPv4 entry, IPv4 resource record entry for a particular domain, right? So this is the IP address, right? So if you have 4 A's, which means that is an IPv6 resource record, okay, or IPv6 entry for a particular domain. Okay, check your output and see. And what you can do, another thing, but you can actually run the dig several times and see if this value changes.
So for the UCSC ucsc.lk, that search record given the 192 address. UCSC, no, not that one. ucsc.lk, the answer section.
Yes, you should get like 192, 248,
22,
16 or 22,
125. Yeah. Oh.
So this is the public IP address.
Ah, okay.
192 and 68 is private.
Ah, okay.
Okay, check කරාද value වෙනස් වෙනවා.
Yes, sir.
අඩු වෙනවද වැඩි වෙනවද එකපාර වැඩි එක වෙලාවක්දී වැඩි වෙනවා. ඒ කියන්නේ අලුතෙන් එකක් ගත්තා කියන එක.
තාම 1800ද වැඩි වෙනවා. ucsc.lk එකට 1800. ඒ first time ගහන ඉඳන් නේද?
Right, okay.
First time in there.
Okay, so these are the types of records that you can find commonly. A record for IPv4, 4As for IPv6, NS for domain names, MX for mail servers, and PTR, pointer records. This is if you want to resolve or if you want to get a domain name for a particular IP address, then you need to have these PTR records. Right? So that is for reverse lookup. Yes.
දැන් සාමාන්‍ය අඩු වෙන්නේ නෝන වැඩි වෙනව නම් මොකද? වැඩි වෙනවද?
වැඩි වෙනවද අඩු වෙනවද?
නෑ අඩු වෙවි ආවා. අඩු 50 වුණා. ආපහු 160 වුණා. ආපහු 260 වුණා. ආපහු 51 වුණා. එහෙම වෙනවද? සාමාන්‍ය අඩු වෙලා 160 නාම පටන් ගන්නවා. දැන් ආපහු 300 වෙලා 24 වෙනවා. මෙහෙම මාරු වෙනවා. සමහරට අර රෙකෝඩ් එක දාමු ඉඳන්
ඔව්.
ඈ? ඔව්.
ඊට ඕක මේ දැන් ගොඩක් ළඟ නම් වෙනස් වෙන්නේ ඔයාලට ෆ්ලක්චුේෂන් එක වැඩියෙන් පේන්නේ. අපි කියමුකෝ ඕක හැබැයි එච්චර ළඟ වෙනස් වෙන්න හේතුවක් නැහැ. ඕක සාමාන්‍ය පැයක් විතර තියෙන මේ විනාඩි 30ක්වත් තියෙනවා නේද? සමහර සයිට්ස් තියෙන්න පුළුවන් ගොඩක් ළඟ වෙනස් වෙන්නේ.
Google
සයිට් එක.
google.com.
වෙන සයිට් එකක් ගන්න Google.
UCS එක නම් එන්න අඩු වෙනවා.
AIP එකට තියෙන
AIP
එකද?
එකට තියෙන TP.
right. ඒක උනොත්.
Hi. Okay. So PTR records is that. Now CNAME record is now like let's say when you are configuring a DNS, right? Let's say you have a www mail port like let's say 192.248.22.125, right? Now let's say you are okay, not www, let's say PGVL. Your UGVLE is also in the same IP address, right? So then what you do is you don't put a record, instead you use a canonical name record and put PGVLE. So that when you change this IP address, all the things get reflected. So this is a kind of an alias to maintain it. So if you have a record, then you have to change all the IP addresses. But if you have a CNAME record, you refer to this. So that if you change this, all these things get changed. Okay? Right. So that is CNAME. මේ reverse lookup එක ගහලා බලන්න. වැඩ කරනවා මේ IP නෙමෙයි. Google හරි මොකක් site එක IP එකක් කරගෙන.
CNAME එක use කරන්නේ subdomain වලට.
Oh, subdomain වල use කරන්නේ. මේක subdomain දැන් PGVL වගේ PGVL
UCSC.lk.
Oh, දැන් මෙතන අපි දාන්නේ නේද PGVL එකේ තියෙන UCSC.lk කියන zone එක find කරනවා. එතකොට මේ විතරක් දැම්මම CNAME records මේක දාන්නේ. multiple මේ IP එක කරනවා නේද?
සර් ඒ රෙකෝඩ් කියන්නේ UCSC කියන්නේ නෙමෙයි
නෑ. ඒ රෙකෝඩ් කියන්නේ හැම එකම මේ CNAME එකේ ඒකේ වෙනසක් නැහැ. වෙන එකම වෙනස තියෙන්නේ මේකට IP එකක් දෙන්න ඕනේ මේක දෙන්න ඕනේ. ඒ රෙකෝඩ් එකේ මේ එන්ට්‍රි එක මේක ලයිසන්ස් දෙකම එක. මේ CNAME මම හිතන්නේ IPv6 IPv4 කියලා වෙනසකුත් නෑ ඒක බලන්න ඕනේ. හරි රිවර්ස් ලුක්අප් එක වැඩ කරාද?
PTR record එකක්. PTR record එකක්.
ඒකේ මේ ඩොමේන් එක දුන්නම IP එක එනවද? sorry IP එක දුන්නම ඩොමේන් එක එනවද?
domain එක නෙවෙයි ආවේ because in.address
එහෙම නෙමෙයි. ඕකේ ඔහොම ගිහලා එන්න ඕනේ වල අන්තිම ඇඩ්‍රස් එක.
සමහරවල් මම විතරයි address 100ක්
Google නෙමෙයි.
වෙන එක.
මේ ඇවිල්ලා තියෙන්නේ Google නෙමෙයි වෙන මොකක් කරේ සර්ච් කරන්න. Google එකේ තියෙන්නේ වෙන වෙනම.
සර් මේ NS ලුක්අප් එක අපේ ගණිත රිසල්ට් එකේ non authoritative answer කියලා එන්නේ.
non authoritative answer කියන්නේ ගොඩක් වෙලාවට cache එකකින් එන එකක් වෙනවා. මොකද හේතුව authoritative එකකින් තමයි direct link. ගොඩක් ඒවා non authoritative ඇත්තේ.
ඒ ISP
කොහෙන් හරි cache එකකින් දාන්න. cache එක කොතනද කියලා හරි මොකක් බලන්න බෑම කියලා.
එන්නුනා
DNS server එක දෙන්න. ඒවා DNS server PTR එක තියෙනවා රිවර්ස් ලුක්අප් එක. ඒකත් අර විදිහම යන්නේ. පොඩි කියන්නේ කොහොමද? ඒකෙදි වෙන්නේ ඒක මොකද ප්‍රශ්නේ? ඒක ඇත්තටම මම හරියටම දන්නේ නැහැ ඔක උත්තරේ. PTR රෙකෝඩ් එකකින් ඩික්ලෙයාර් කරනම ඕකේ බලන්න කැඩි කැඩි යනවා. පොඩ්ඩක් මේක දාලා
UCSC එක ගහුවම anduna.cmb.ac.lk කියන.
මොකද?
anduna.cmb.ac.lk කියන. UCSC.lk එකේ හරි රිවර්ස් ලුක්අප් එක ගහුවොත්
ඔව්
anduna කියලා.
අඳුන ගොනෝ අඳුන ඇඳුනා කියන්නේ අඳුන අඳුන අඳුන
ඒක රිවර්ස් ලුක්අප් එකක් ගහුවා. name server එකේ ඉන්නේ නේ.
ඔයා බලන්න ඒකේ එයා පටන් ගන්නවා ඒ PTR රෙකෝඩ් එක පටන් ගන්නවා DTR එක වල පස්සේ අපි ඉතින් මුලට යනවා ඒක 192 කියනවා හරි දැන් මම 192 මෙතන හරි ඒක ඇවිල්ලා මුලට යනවා එයා මම PTR වල තියාගන්න ඕනේ මේ IP තියෙන කොහෙද කියන එක වෙනම තියෙනවා DNS zone එකේ නැතු ඒක වෙනම section වෙනම විදිහට තියාගන්න ඕනේ ඒක මුලින්ම මුලින්ම ගිහිල්ලා නම් ඇති 192 IP address ගන්නවා තියෙන්නේ ඊපස්සේ එතනට යනවා ඊපස්සේ එහෙම IP ටර්ම් එකේ වාගෙන යනවා ඇති අපිට යනකල් යනවා එහෙම නෙමෙයි මම
name server එකේ ඉන්නේ නේ සර් රිවර්ස් ලුක්අප් එකේ.
රිවර්ස් ලුක්අප් එකේ දැන් name lookup එකේදී dot එකකින් හොයනවනේ කෙලින්ම. දැන් IP එකේ අර dot එකක් තියෙනවා. ඒකට ඒක root එකට කොහෙද ගිහින් PTR records වෙනම maintain වෙනවා. IP level එකේ කොහොමද domain බෙදලා යන්නේ කියන්නේ. අර 192 addresses කොහෙද තියෙන්නේ. ඒක ඊට පස්සේ ගියාට පස්සේ ඒකේ point එක ගාඩ තියෙනවා.
අර රිවර්ස් ලුක්අප් එකේ domain එක නෙවෙයි එන්නේ.
නෑ නෑ. domain එක තමයි එන්නේ.
name server.
name server එක විතරද එන්නේ?
ඔව් name server විතරයි.
නෑ name side එක ඉස්සරහ ඉදිරියේ.
Yeah.
ඒ අන්තිම PDR එක තියෙන තැනට එන්න ගන්නේ.
අපි ISP දාලා දෙන්න PDR එක එන්නේ. එතනින් තමයි නේද?
හැබැයි දෙන්නම වෙන්න බෑ.
ඔව්.
ක්ලාස් එකේ නම් වෙන්න බෑ. අනුත් රෙකෝඩ් එක දෙන්න දෙන්නේ. ඊට පස්සේ කෑල්ල කාලා දෙන්නේ. ඉන්නේ මෙහෙම රෙකෝඩ් එකකින්. DNS විදිහටම එක විදිහකට තමයි යන්නේ. හැබැයි යන්නේ වෙන අවසෝන්ස් වල නෙමෙයි. වෙන මොකක් හරි PDR වලින් තියාගන්න
PDR වෙනම ISP level එකේ
තියාගන්න
ඒක වෙනම රෙකෝඩ් තියෙනවා.
ඒක දන්නේ කොහොමද? Right. Okay. So in this name server, there are few types of name servers, as I mentioned. One is authoritative, the other one is recursive, and the other one is cache name servers. The authoritative name servers like root, TL, top level domain name servers, and the actual servers keep the entries. Those are authoritative name servers, right? And the recursive name servers, which we have, like let's say in our local domains, there are recursive domain name servers who would do the job for us, right? So those are recursive domain names. And cache only domain name servers does not keep any configurations, right? So those will be only keeping caches to improve the performance. That's it. Okay?
So අපි යන socks කියලා use කරන browser වල socks
Socks.
UI
Oh, එහෙම එකක් තියෙනවා. ඒක මම දන්නේ. අර මේ proxy එක configure කරන්න ගියාම තියෙන්නේ.
ඔව්.
නෑ ඒක මම දන්නේ නැහැ.
සමහර ස්පීඩ් වැඩි කරගන්න ඕන නම් මේවා socks ගන්න
ඔව් ඒක caching scene එකක් වෙන්නද ඒ හරියට ෂුවර් නෑ. මම use කළාම නෑ ඒක. ඒක මොකක්ද කියලා. ඒකත් මොනවද ඒක බලන්න දන්නේ. ඒක තමයි තියෙන්නේ process. Socks. Right. Okay. So okay. So let me simplify this. Now these name servers, there is a fault tolerance mechanism for these name servers, right? So if a particular name server goes down, there should be someone else to take it over and give the resolutions, right? So there is a concept called master and slave in these domain name servers, right? So slave domain name server will be kept offline. It will not actually answer any queries. Only master name server, authoritative master name server will be giving the answers. Now, if for a certain circumstance or for due to a particular incident, let's say the master server goes down, then the secondary server becomes the master and server, right? So there is time to time, like let's say updates happen in between these two servers. Generally, the update process is initiated by the secondary server. Secondary server time to time ask, okay, is there any update from the master? And master server responds, let's say no. So again asks, if there is an update, then it gives the update to the secondary server, so that secondary server will update its let's say zones. So this process of taking updates, the process is called a zone transfer, right? It is a zone transfer. So you don't want to know about the minor details, like let's say now these domain name servers runs, okay, let's know it, talk about that as well. These domain name servers runs both in UDP and TCP. Port 53. Okay, so all the queries go through UDP due to the performance. Right? Only the zone transfer happens in TCP. Right? Zone transfer initiation also happens in UDP, but the transfer happens in TCP. Sometimes when the UDP is not responding, queries could happen in TCP, but it is highly unlikely. Okay. මොකද දුරි?
ෆිෂින් එකක් ඒකට මේ ලයිසන්ස් කරේලා ක්ලික් කරුවට ෆොටෝ කරේක
ඒ issue එක දැක්කද?
නෑ ඒ කියන්නේ අපි DJ රිටයර්ඩ් එකේ එයා කතා කරලා මම ගැලෙවලු මෙයා යනවා කියලා.
Right. So there is fault tolerance, right? So there is DNS protocol level fault tolerance. There could be other fault tolerance like let's say multiple servers and so forth. The office එකේ Okay. අපි zones ගැන කතා නොකර ඉන්නද? ඉතින් So, what I will do is I will give you an activity that you don't have to do it here, and it is not an assignment as well. Right? It is not an assignment as well. Just to learn about how DNS works, right? So I will give you an activity so that you can work leisurely, maybe after the exams as well. Then because I think question in there, just to know how things work. Right. Okay, so now a zone. Zone means now like let's say when you take this UCSC, it is a zone, right? So we have so many subdomains. We have like let's say 200 or subdomains. What you see is actually few, but internally there are so many other domains. What you see would be www, pgvle, and gcat, gcct, those things you might be seeing, right? So these subdomains, it is not depending on the geographical location or the servers or whatever. So it's logical something, the zones, right? So the last sentence, I think you should know this now. Zones are strictly used for delegation control. So as we mentioned, these links a particular zone file, right? These NS entries. Okay. So this is the start of the zone file, and there are the entries coming after that. So there are so expiry times, refresh, and there are few attributes which you don't need to know. So anyway, when you are configuring it, you might get to know about those things. So that is about DNS, right? So after the tea break, we'll discuss about the attacks, right? This cache poisoning is a problem. So these queries can intercept by someone and change locations, a problem. Even the resolution, they can intercept and change them. So there is a problem with the integrity mainly of the entire protocol, right? So in security, how you manage integrity? Below second semester, right? First semester, it's the second subject.
Certificate.
So
CS.
integrity. How you manage integrity?
Hash.
Okay, hash. You hash it. Okay. Hash the message. Right. Now this provides you integrity. So now let's say we maintain integrity. How you maintain non-repudiation? Signature. Okay. So can you explain how signature works? Okay, let me rephrase the question.
Last digit.
Versus signature.
Last digit.
Sure. Message authentication code signature. They came hash used. encryption එකක්. message authentication code එක
hash
encryption
එක
එක.
repeat කරනවා.
හා?
message එක hash එක ආපහු repeat කරනවා නේද? algorithm එක use කරලා.
මේක encrypt කරනවා. encrypt කරනවා කියන්නේ encrypt කරනවා. කොහොමද encrypt කරන්නේ? encrypt කරනවා හරියට.
Recipients public.
Recipients public key. Recipients public. Ini මොනවද?
recipient එකේ ආපහු repeat කරලා hash එක ආපහු ගන්න හදන chat එක match.
ඔව්. එතකොට දැන් ඔය වගේ එකක් මේකට දැම්මොත් හැම එක්කෙනාටම පබ්ලික් කී තියෙනවා මෙයාගේ. නෑ. ඔව්. එකක් හැම එක්කෙනාම පබ්ලික් කී තියෙන්න ඕනේ. ඔව් හැම එක්කෙනාම පබ්ලික් කී තියෙන්නේ මේක මොනවද? නෑ ඉතින් යූසර් කෙනෙක් sorry? අද මම කරන්නේ.
Senders public.
Senders private.
ඒක වෙන්න බෑ.
ඒක මොකද?
ඒ කොහොමද වෙන්නේ? එතකොට ප්‍රයිවට් කී එක අතර නැහැ.
සෙන්ඩර් ප්‍රයිවට් කියන්නේ
ආ නෑ.
ඒ කියන්නේ මෙයාගේ ප්‍රයිවට් කී එකකින් යා
ආ.
එන්ක්‍රිප්ට් කරනවා. ඒක මොකද? රෙසිපියන්ට් DNS එකේ පබ්ලික් කී එක. ඒක මොනවද වෙන්නේ? මොකද්ද? ඔව් අතට ඒක තමයි සිග්නේචර්. යාට වෙරිෆයි කරන්න පුළුවන් මොකද ප්‍රයිවට් කී එක දෙන්නේ මෙයා ගාව විතරයි. ඉස්සෙල්ලා කරේ සිග්නේචර් එකේ ඉස්සෙල්ලා ප්‍රයිවට් දැම්මොත් මේක එන්ක්‍රිප්ෂන් එක. මේක ඩිජිටල් සිග්නේචර්. මෙයාට ඒක මොකක්ද? සීක්‍රට් කී එක. ඒකත් එන්ක්‍රිප්ට් කරනවා නේ. නේද? මේ හැෂ් එක කියන්නේ ඉන්ටිග්‍රිටි එක මේ හැෂ් එක. ඔතෙන්ටිකේෂන් එක මේක වෙනවා. ප්‍රයිවට් කී එකකින් දා. මේක කොහොමද වෙන්නේ? සීක්‍රට් කී එක. ආයෙත් ෆිෂර් කී එක. නේ. මේ දෙක වෙනස. මේක නම් ලික්විඩේෂන් නෑ. මේක ෆිෂර් කී එක දන්න ඔතොරයිස් පාටි එකක් තමයි වෙලා තියෙන්නේ කියලා ඉතින් දන්නේ. මේක දන්නවා එක්සැක්ට්ලි කවුද කියලා. ඒක තමයි දෙක. හරි? මතක තියාගන්න ඕන වෙනවා. හරි. right. Okay. Now okay, now here, when this guy responds, right, responds to this particular query, let's say, it has a response message. Now this is, let's say, UC authority user. So it responds with the message, right, to the client. To the, let's say, recursive DNS, let's say, which is basically the agent of the client. DNS server, which then goes to the client. Right? Okay. Now this can be intercepted at the middle. Any problem with? Take a problem. This can be intercepted at the middle. So what do? We need to implement integrity. How we do that? How we do that? Thank you.
Encrypt private key.
Okay, you get a hash of the message. Message is here. You put it like that. Ne? මෙහෙම කරලා දැන් hash එකක් මේකත් එක්ක යනවා. ඔන්න මම දැන් යෝනික් එක කරගෙන hash එකක් වෙනස් කරලා දෙයි. So what do?
Encrypt.
You මොකද කරන්නේ?
Encrypt කරනවා.
ටිකේ වලට Mac එකක් පාවිච්චි කරනවා. Message පාවිච්චි කරනවා. Now let's say message authentication. You are using message authentication for one. You need to have pre-shared key, right? Two, there is a requirement where you need to check whether this is the original response. I mean, the response from the original server. Can you use Mac for that?
You can, as long as you know other,
If you want to do that, then for each such recursive domain name server, you have to have different pre-shared keys, and you have to have a map of that. Otherwise, you can't. So this is not going to work, right? So what you do is you are signing it. You use a digital signature. Okay. So digital signature, hash of the message, then you encrypt it using the authoritative server's private key. Okay. Mum may use Kerberos again notations. We may did not use again. So take on use that, right? Okay. So this is the signature. So for signature, what do you need? Public key and private key. So for this guy, you need private key of A, public key of A. Okay. A means this guy, authoritative server. Okay. Now you have a signature. Now when you go here, then you get this public key of A. Anyway, you have it because it is public. So you can verify this is from the authoritative server. Now the problem is solved. You see? Easy. Problem is solved.
same reason that the server. Why we use DNS?
Sorry?
Why we use DNS is for, because of that. Then we can't be sure the public.
Now the problem was the message can someone can at the middle change this. Right? Okay. So you do this. Right? And save it. Okay? Since you have this public key, you can verify it. Now what is the problem? මම පොතෙන් ප්‍රැක්ටිකල් ලෝකෙට ගෙනියන්න හදනවා. ඒ ඇයිද මේක හරි? ගිහිල්ලා සොලියුෂන් එක දෙන්න ගියා. ඊට ඩෙවලොපර්ස්ලා උරුරුන්ට මොකක්ද Then certificate sudah dikirim. Private key signature kan, itu kan. public key එක තියෙනවා. ඒකෙන් verify කරන්න. authority user එක මොකක්ද ඒ ප්‍රශ්නේ?
එයාට පබ්ලික් කී එකෙන් එයා ගාව තියෙන හින්දා එයාට ඩීක්‍රිප්ට් කරන්න පුළුවන්. හැබැයි ඔව් හැබැයි එයාට ආපහු චේන්ජ් කරාට වැඩක් නැහැ. මොකද මෙයා බැලපු ගමන් එයා වෙරිෆයි වෙන්නේ නැහැ නේ අරකින් කියලා. ප්‍රශ්නේ මයිද එදා කිව්වනේ. ගිය පාර කියලා දෙද්දි. මේකෙන් ප්‍රශ්නයක් තියෙනවා ප්‍රශ්නේ මතකයි.
Initial problem was actually from the authority server there is a response. IP address is coming. Make it right? So before going there, you will verify that you are getting it from the original party. This problem we had in the kernels as well, but we dealt it in a different way. So now we agreed that we can use signatures. This is the signature. So we sign this message and send it so that this guy can verify. This is from this thing. So now how this public key came here? That is a problem. Right? So either someone should have a central trusted body as certification authority. There should be someone who tell that okay, this is the public of this guy. Trusted third party should be there. Right? So in this case, it is not. It seems, right? The other problem is how you distribute this public key. Right? So the distribution happens actually through this. Within this, it sends public key of A. So that this guy gets it, and okay, public key is there, can verify. And problem is actually there could be a man in the middle where instead of this message, he will attach his public key and his signature and his message. So that when it goes there, he can verify. It's true. It's original there. That problem is there. Because there is no trusted third party. Okay? Right. So problem is solved, but it is incomplete. So the key used for this purpose we call zone signing key. Zone මේක ලියාගන්න ඕනේ මම YouTube වීඩියෝ දෙකක් දෙනවා. ඒකේ මේක ලස්සන නිකන් ඇනිමේට් කරලා පේනවා. මොකද ඒක උඩට වදිනවා. හරි. ඒකේ නෝට් එක හදාගන්න. zone signing key. Right? So what this guy will do is this guy will now this is for particular zone, particular resource record is doing this, right? So generally they do it for resource record set. So what is a resource record set? You will find it in the video. right? For now, think about of it as a resource report. For a particular resource report, they are doing this using zone signing key. So for the entire zone, right, there is another key that they have. So it is called key signing key for the entire zone. The particular zone, there is a key signing key, because now this has happened because for a particular zone there would be sub-zones and so forth, and you need to certify this public key that you belongs to this zone, right? So what you do is, by using this zone signing key, you sign this. You sign the public key. Then this becomes a certificate, right? Then this particular key signing key, now there is now when you take the hierarchy, now we are still at here, right? We are still at here. In the hierarchy, there is another TLD, right? So for TLD, there is another key signing key, right? For actually for TLD, there is another key signing key and a zone signing key. Why they need a zone signing key? Because they are sending these NS records as reference. So those should be also authenticated. So those NS records are resource records. So you sign resource record using zone signing keys, right? And you sign this using this key signing key, so that they approve you are authorized, right? And they sign their key as well, so that they have a certificate there. And this hierarchy goes on till root, right? Then at the root, there is no one above, right? To give him a certificate, there is no one above. So what is the process there? මම කියලා ඕගොල්ලෝ දන්න දෙයක් කියන මේ ඉක්මනට යන්නේ. මේ certification authority ම තමයි මේ. There could be sub certification authorities, another sub, like, so sub ones get approved from the higher ones, they get approved from the higher ones, right? But at the top, there is no one to approve them. What happened? Still, ownership is one. Can I come on? At the root service, the Hatman team. It is root service. So, who's going to own the root? No. ඒක ඇවිල්ලා consensus වගේ එකක් ඔයා හිතන්නේ agree වෙනවා ඔය කතා කරන්නේ නේ GPG නෙමෙයි ඒකේ root එකක් නැහැ PA process එකක් නෙමෙයි
mutually එයාලගේ මේ trust එකක් හදාගන්න
web of trust GPG ඒකේ root නේ ඒක තමයි email signing වලට පාවිච්චි කරන්නේ මේ අපි කතා කරන්නේ certification වල ආගියක් තියෙන්නේ ඉහිලා root එකේ දාන්න ඔයගොල්ලෝ ගණන දින මොකටද ගන්න So at this point there is something called ceremony or something like that. Remember the name of the ceremony. Whatever, there is a ceremony where there is a specific way of creating the initial private and public key, right? There will be so many people gathered. That is a public event where there are specialists and there are so many parties involved. So that is ceremonial event with multiple evidences, right? And they create that and use that afterwards, use that for the rest of the things. So based on the trust on that particular ceremony, we build trust on these things. Each generation. Root key ceremony, yes.
Cousins are
Cousins are given in CA given. නැත්තම් මේ third party trust එක කොහොමද විදියක් නැහැ. දැන් ගිහින් කියන no third party ඔයගොල්ලෝ trust මේ issue කරන certificates ඔයාලා කොහොමද trust කරන්නේ? and they trust. Okay. Now the problems was the cache poisoning problem can be solved. How? Now there was a problem here. So we can solve it because using this and the certificates and all that. Right? Then same problem appears here and here. Again, same thing can be resolved using this. It could be in this case NS records. This is resource record. All these situations you are sending NS records, right? In this case you are sending a resolution record, or let's say the IP address. All these things are resource records. Right? NS, A, PTR, MX, all are resource records. Right? So everything, every response is a resource record. So resource records, you can do this. Right? So then this part gets secured. You can check whether these are original servers, and since the integrity is there, you can check whether it is modified or not, because signature is there, right? So the signature, since the signature get cached here as well, right? You can at any time verify with respect to the trusted third party. So cache poisoning won't work. So then this problem gets solved when you have that. Got it? That is called DNSSEC. DNSSEC is not a replacement for DNS. It is something implemented to protect DNS protocol. Okay? Right. Then
tools before ඊට පස්සේ